All right, ladies and gentlemen, let's talk about Pythagorean theorem and its converse. I know that we have talked about Pythagorean theorem plenty before. So we have our a squared plus b squared equals c squared. This helps us prove that it's a right triangle. So let's just go ahead and look at a couple examples here. So in the first one, the right angle is here. So x is my hypotenuse. So we have 6 squared plus 15 squared equals x squared. All right, so 6 squared gives us 36, and 15 squared is 225. So let's go ahead and add those together. 36 plus 225, and we get 261 equals x squared. Now we want x to be by itself, so we're going to go ahead and take the square root on both sides. So when we do that, let's round to 1 decimal place here. We get 16 point, and it's 15549, blah, blah, blah. So the 1 and the 5 rounds up to 2. So if we look here at problem 2, my right angle, so that makes 11 my hypotenuse. So the x and the 9 can go in either order. So we get x squared plus 81 equals 121. So we're going to take and subtract the 81 to both sides. So we get x squared equals 40. Okay, again, we're going to take the square root on both sides. And so the square root of 40 is 6.3. So just some basic Pythagorean theorem problems we've done before. So we have Pythagorean triples, and I know you've heard me talk about them before. So here's some common ones, that if you have the sides 3 and 4, your hypotenuse is going to be 5. These are like little shortcuts. If you memorize that, then if you ever see a triangle and you're like, oh, hey, the hypotenuse is 5 and a side is 4, then this has to be 3 because it's a Pythagorean triple. Another one is 5, 12, 13. And then 7, 24, and 25. These three are probably the most common, most recognizable Pythagorean triples. Now, Pythagorean triples can also be multiples of them. So if I take everything times 2 and get 6, 8, 10, this is also a Pythagorean triple. Okay. If I times my next one, 5, 12, and 13, we get 10, 24, and 26. And then the last one, we get 14, 48, and 50. These are all common Pythagorean triples because they're multiples of original ones. If you times it by 3, we get 9, 12, and 15. Let's see here, we get 15, 36, and 39. We have 21, 72, and 75. If you times by 4, we would have 12, 16, and 20. We have 20, 48, let's see here, 13 times 4, 52. And then 7, turns into a 28. 24 times 4 gives us 96, and 100 times 4 gives us 25 times 4 gives us 100. So common Pythagorean triples, things that if you see occur, they're like shortcuts. All right. So let's go ahead and talk about the converse of Pythagorean theorem. So if you know, and we've used this part of it before, if we know a squared plus b squared equals c squared, then we can say, hey, it is a right triangle. Okay, if you look back at the original, it says, hey, it's a right triangle, therefore we know a squared plus b squared equals c squared. Okay, on this next one, I actually think that your notes is written like a squared plus b squared is greater than c squared. Okay, so this says that when I add a squared plus b squared and it's bigger than c squared. So c squared is small. Okay, it's an acute triangle. Okay, then Again, this is flipped. A squared plus b squared is less than c squared. So this time our c squared is big. It's an obtuse triangle. Oops. And now you might want to add these little drawings here. These are not on your notes, but it might be helpful to have them there. So go ahead and pause the video here. Also, this is my time. I'm going to tell you that I'm going to check your notes in class tomorrow, so make sure you have them all written. We'll see how many of you catch that. All right. So let's go ahead and use this. It says determine whether each set of numbers can be measures of the sides of a triangle. So first we need to make sure it's a triangle. And then we're going to classify it. So just a reminder, how do we know if a triangle or if three numbers make a triangle? You have to take the smaller two and add them. And the question is it bigger than the third one? Well, 7 plus 14 is 21, which is bigger than 16. So it is a triangle. So now we move into the classifying part. So we take our two smaller sides and we square them. And I'm going to leave a blank with a question mark because I don't know if that is greater than or less than or equal to 16 squared. All right, so 7 squared gives us 49. 14 squared is going to give us 196. And 16 squared gives us 256. So I'm going to take 196 and I'm going to add 49 to it. And I get 245, which is less than 256. So my c squared is greater. So that makes this an obtuse triangle. All right, let's go ahead and look at our next one here. We have 9, 40, and 41. So first I just want to double check to see, is it even a triangle? Okay, well 9 plus 40 is 49, which is greater than 41. So this is, yes, this is definitely a triangle. So now we're going to put it into our form. So 9 squared plus 40 squared, we don't know what that is in relation to 41 squared. So if we look, 9 squared gives us 81. 40 squared is 1600. And then go ahead and take 41 squared. And that's 1681. So I'm going to go ahead and add my 81 and my 1600. So I get 1681. Hey, that's equal to 1681. So this is a right triangle because they turned out equal to each other. All right, let's look at the next one. First, we need to make sure that it's even a triangle. So, oops. Well, 1 plus 7 is 8, and 8 is not greater than 8. So this is not even a triangle. Not a triangle. All right. Let's bring up our last problem today then. All right, so here it does give us a right angle, so we do know that this is a right triangle. So that means that x is my hypotenuse. So we're going to solve for x by plugging this into quadratic formula. So we have 8 squared plus x minus 5 squared equals x squared. So all I did was plug my two shorter legs into my a and b, and x in for my c. So 8 squared gives me 64. Now this next one, it's x minus 5 squared. I can't just distribute in my square because square means times by itself. So I have to write out x minus 5 times x minus 5. And to complete this, we are going to FOIL or box method. And I like FOIL. That's what I'm used to. So I'm going to write FOIL, show FOIL here. So I add x times x, so x squared. X times negative 5, so negative 5x. Negative 5 times that x, so I get another negative 5x. And then negative 5 times negative 5, so plus 25 equals x squared. All right, so I see some like terms, negative 5x and negative 5x. So that's going to give me a negative 10x. Because remember, we don't do anything with the x terms. I have a 64 and a 70 or 25, so that gives me 89. And then I have a plus x squared and equals x squared. Well, if I have an x squared here, I'm going to subtract it over, and that actually cancels out on both sides. Woo, there it went. Always happens, guys. All right, so what I'm left with is negative 10x plus 89 equals, oh, nothing, so that's over there. So now I'm going to go ahead and add 10x to both sides. So I have 89 equals 10x. So to get x by itself, we're going to divide both sides by 10. And 89 divided by 10, so we get x equals 8.9 for our solution. All right, there you go, ladies and gentlemen.